Thank you. Good evening, all. Hope you guys got your pizza. Sure. Let me know if you guys feel bored. I can move out of this. So today we're going to discuss the cloud native architecture. I would rather say that it's more an architecture perspective. You look at it. You can discuss various patterns. We'll be using Spring frameworks over here today to demonstrate some of those patterns. And I try to put Kubernetes in place. The problem I'm having is fetching the Dockers from the internet is taking at least 55 minutes right now for me. So I don't know how it's going to work over here, but I'll try my best. But in any case, what I'll do is I already have most of the components on my machine, which is for service discovery, for monitoring, for scale out, scale up, scale down. All these things I can show from my machine also. Kubernetes and Docker is mostly for packaging and deployment. If anyone have any questions, I can share some of the commands and everything, but at least we can get started with how to generate the Dockers and how to see the Kubernetes also. But coming back to the architecture alone, before I move on, let me give a small introduction about myself. So I work for Cognizant Technology Solutions. Along with that, I also have my own company, a small shop of my own. And I started a couple of companies. I failed big time. No offense, but I failed very badly. One of the companies is Hug Innovations, where in 2012, we started with smartwatches, actually. But Fitbit came over and just galloped us, and they said that, guys, you guys doesn't make sense because you guys are charging $200. I'm doing for $70, $80, so get out. So we don't have an option, but we keep selling our watches. It's still there in Amazon and everything. I think right now you see out of stock. But anyways, that's one of the companies we started in 2012. Then as I mentioned, I made enough mistakes to call myself at least an engineer or an architect. So that's where I am. And I work with major customers. You can see the list of customers, and it keeps going. I typically speak for Philly because I come from Pittsburgh. So I speak at Philly, Pittsburgh, and recently I started speaking at Baltimore. And this is the first time I'm coming to Virginia or DC user group. I worked on most of the industry-leading platforms. It's not that I got opportunity at the client sites to work or I got opportunity in my own project. It's more like the demand drove me, and also it's my passion to move forward. So that's why I worked on those things. I love music. I love music, Indian music, and I love eating biryani. By seeing my size, you can understand I eat a lot. And I live in Baltimore, but I'm a great fan of Steelers. No offense, that's a fact. Okay, so let's speak a little bit about cloud architecture, right? Cloud architecture doesn't mean microservices. That's the first misconception I want to remove. So cloud architecture leads to three different types of patterns or architecture, which is service-based architecture, microservices architecture, and event-driven architecture. So any customer can, or any of the projects can always go with any of these architectures. And it's just a matter of how you package, how you deploy, and how you are going to utilize your platform, and how you isolate your layers from a business perspective along with the technology. So that is why this cloud native architecture and patterns are very different from, or it's a combination of various patterns and architecture, not just microservices. No project, in my experience, no project sustained with just this architecture. We always run with all the three architectures. Now, the advantage over this one is some organizations or some customers or some projects might come up with a bottom-up approach, and some come with a top-down approach, and some come with the on-demand approach. So either ways, you will end up having all these things. Reason being, there is always a greenfield implementations and brownfield implementations. So that is the reason we always do a combination of these three architectures. Now, with these three architectures, the benefits, I know by now, most of you guys would have Googled what is microservices, and some of you guys would have already implemented it. But you know the benefit of it, of all these things. So let me not go into those details of it. But as always, I'm also a great fan of making fun of any new architectures. Trust me on that one. When SOA came, I used to say, what is this SOA? We used to have the services since long back. Then microservices came in. Then I made fun of microservices. Then APIs came in. Then we said, okay, APIs is nothing but microservices again. But trust me, all these architectures mathematically has its own definitions. So for example, when I take any of these architectures, I apply when I choose each and every parameters of these architectures, I apply mostly the CAP theorems: consistency, availability, and partition tolerance. So it boils down to what is your requirement and where you need to apply your consistency, availability, and partitions. So that way, that drives your complete direction towards your application building. For example, here might be partition tolerance makes sense as compared to just consistency and availability, right? Here, consistency and availability, there is consistency and availability. So mathematically, you have a lot of differentiations. And on top of it, you are changing the state from A to B to B to C, all these things, whenever this whole communication is going on. So that's why the architectures are a combination of these three. And we have various patterns also in place, right? So we follow the brick and mortar, and this is the fundamental way of approaching most of the patterns recently we started adopting, and we see the value over there. So brick and mortar is purely like how you construct your house. We call the brick patterns are the fundamental patterns, and the mortar patterns require to ensure that all the bricks have to be applied. So that's why we started with brick and mortar patterns. I hope you all know the 12 factors, so I will not delve into those details, but let's spend some time on these patterns and how many we are going to see today. So these brick patterns, we call this externalization of configuration, externalization of channel, and state. So most of these are stateless. So in microservices or in cloud native patterns, we typically ensure that you don't hard code any value. Every value is externalized, no matter what. Even if you want to write something in application properties, you should be very mindful where you want to mention versus where not you want to mention. So typically we externalize most of the values, and that is configuration, including the channels. Sometimes we externalize the channels if the channels are multiple, but if it is only one channel, always we'll keep it internally. And state, we always make it stateless, and the state is always externalized to some kind of caching service or some kind of file repositories or storages. Now, runtime. So we always ensure that whatever the configuration which is externalized, it has to be reconfigured, which means if I have a configuration value of XYZ and tomorrow I want to change it to 1, 2, 3, I should be able to change without bringing down my application. So we should, dynamic reconfiguration is mandatory in this. So mostly the concurrent execution, and concurrent execution is at a time I can always ensure that 3 or 4 services can execute, and if just in case if any of the services fail, we need to have the events captured. So concurrent execution is always mandatory in our distributed application. We have to monitor each and every isolated brick, because a brick can be let's assume that your brick is a config server. Okay, now if your config server goes down, your whole system is down. Assume that you're getting your connection string, which is externalized to a system called Vault or somewhere. Then if you're trying to fetch that value and your config server goes down, your whole system is down. So obviously, is there a single point of failure? Yes, there is a single point of failure. But you need to be very careful. That's why the scale out is mandatory and telemetry is mandatory for all the bricks as well. Now for all these motors, so assume that for all these bricks, I need to apply the motors. Just like concurrency execution, I need to apply event-driven systems. For telemetry, I need to ensure that, for example, config server is being called in your web service. Let's take you have a customer service, and you're trying to fetch the database connection string from the config server. Then you need to ensure that if config server goes down or if customer service goes down, your application has some impact. So you need to monitor whether it is config server or the reconfiguration or anything. You need to keep monitoring that. So that's why we need to ensure the integration telemetry of across the containers is mandatory over there. The contract management, that is more like a discipline along with maintenance. Mostly when you are doing container-driven services like self-packaged services, you might have a customer object today, and tomorrow your customer is modified. As per your definition, the customer can be just a customer name and address. Tomorrow you decide that the customer is modified to customer personal details like email address, phone number, etc. In that case, your contract is changing. So you need to ensure that your contract is versioned, and the contract version can be minor or major version. So you need to maintain those things. For all distributed systems, we need fault tolerance. So just in case if my service fails, so service A calling service B and service B calling database, right? So assume that if service A fails to call service B, like right here. So let's assume that most probably we always have these scenarios. I have service A, B, C calling DB, and at the same time I need to validate some rules or something. I have service D. So there is a probability that this goes down, and this goes down, right? So in any case, the alternative approach of any of these things is basically everybody can see. So the approach is, I hope you already heard something called hysterex or circuit breaker patterns. Let's put it that way. Circuit breaker is what we call it as. Now, what is going to happen to circuit breakers is, so let's assume that this fails, right? So we'll go and say a fallback mechanism which says, guys, if I fail, either I will send a response to the service A saying that guys, something is going on, but I'll take care of it. And here you can write an event which again sits in the bus saying that, okay, here it is where it fails, so it's good. Now when service sees, so the further communication, you can always break your delay over here. That is saying like, okay, 20 seconds, I don't want any more requests coming in. I don't want my network to be jammed by sending all the requests and getting a response back. Rather, service B will keep saying that, guys, this request failed, so I cannot give a response back. But I can log these messages into the queue for you. Once it is up and running, typically what we do is the actual transactions will go, and this has to go and take all these transactions and process here. So in a way, what we're saying is, in a fault tolerant, to enable your system fault tolerant, there are patterns like circuit breaker, and for that circuit breaker, there are two things. One is you can have a framework or you can build your own, and then you have to design such a way that you log those events and then publish it to the system. So these are the various patterns. I mean, ideally speaking, these are nothing new. These are all something which we use. Yeah.
So it's with the API key. Like, or if you're bringing from
okay.
So this is like a failover that calling API. Basically, you don't want the API to do. Now, why bring it?
Gotcha. So let's assume that you're going with API gateway. Okay. So API gateway resides here. Okay. And this is where your services are. So this is 1, 2, 3, 4. Now let's assume that now there are gateway means a product you are referring to, or you are referring to a pattern or product. So let's assume that I have a product which can be Apigee or something like that. For Apigee, I need to manually register my proxy over here, right? I need to manually register my service. This will generate a proxy for me, and then my consumer calls this service. Is that right? So assume that I want to scale this up. I want to make this to 2 instances, right? And I want to make this to 3 instances. In that case, I have to register this again over here and make sure that it is calling the same proxy and my gateway will call isolate, right? So there is a manual work which is available. So now, if something goes wrong here, that means, let's assume that this 2 is calling 3, okay? So if 1 is calling 2, and 2 again, it is registered here, 3 is registered here, 2 is calling, 1 is calling 2, 2 is calling 3. If 2 breaks, this gateway will give me a response. But further users, like customer, this is 1, 2, 3, 4, right? So 2, 3, 4 trying to reach the same service, it will not log the request. It will send, it will go to the second, and it will say, guys, third is down, so I'm sending it down. Here, it even don't try to ping here. It will just say, if you are trying to ping this endpoint, then be prepared that it is already down. So I will capture your request. Here you don't have that privilege. The second disadvantage with the gateways is it cannot republish the message to the queue intelligently from the service. The proxy has to republish the message to the queue. You need to write the logic over here using the gateway logic. So that is the drawbacks with the gateway pattern, with the gateway products. Now, if you want to go with the pattern of the gateway, so API gateway was initially a pattern. So if you go with the pattern, then what will end up, you'll end up doing the same logic over here, and you'll just use the pattern over here, which will do the mashup for you. Did it make sense? And by the way, folks, feel free to stop me and ask questions. I want to make it very interactive. Okay. So that is mostly the fault tolerance, and that's where the fault tolerance leads to the two other patterns called service discovery and edge gateway. So so as the gentleman just mentioned, API gateway, the products, we are trying to avoid the API gateways in these architectures, especially in these architectures. The reason being, we'll end up having two. One is the edge service, edge gateway, which is purely on the system side, and we'll keep API gateway on the consumer side. So consumers will only get one endpoint, that is my proxy endpoint. That is my edge proxy endpoint, okay? But behind the scenes, my edge gateway will register all the services so that consumer only will see the API gateway products where they can see what is this API about, what is my contract, how many versions are there. It's purely the developer portals and response caching. For those purposes, we use the consumer side gateways. And these are the server side edge gateways which perform the security logs, any proactive logs or reactive logs on the systems, something like that. And we perform the authentication authorization on the edge gateways, not on the consumer gateways. We'll try to avoid, unless it is a public facing gateway. Now, the next one we have is service discovery. As I mentioned over there, if I want to scale out 2 by 3 times, right? So if it is a gateway product, I need to manually register those 3 times of endpoints into my gateway. Whereas if I go with frameworks or server-side service discovery tools, then we'll end up doing a self-registry, which is agent-driven architectures. We'll show that one too right now, okay? So any questions on these things, on these patterns? Go ahead. Mm-hmm. Gotcha. Mm-hmm. So let's assume that what you're saying is, if I have a stateful services, how can we do it, right? Okay. So most of the services, we typically keep them stateless. And when we go with stateful, there are 2 options we have. What we do is, if again it boils down to the platform. Sometimes it boils down to the platform you're choosing. And if you want to make it platform agnostic, you can apply something like in-memory data grids, like Redis cache, Hazelcast, etc. So in these caching, you can always publish your cache, and the cache is in the format of a JSON object. And whenever you want to read, and each service can have its own character. It's a JSON object structure. So every service, every instance, or every thread can have its own state maintained here. That's one way of approach. The other approach, if you go with the platforms, is they have something called volumes or storages. So you can bind some storage to this service, and that's a fixed volume. And on that, you can always write your files, or you can write some sort of caching or sessions, whatever format you want to have. So that is the other way of. So platforms uses volumes, or they also use in-memory data grids. And sometimes you can certainly call directly this one, which is hosted in another VM or a Docker. Right? That's the best way to maintain the sessions. So, and when any project or any company try to implement this, these are the major things you need to have. First thing is design thinking. The reason for the design thinking is you don't know what problem you're going to run into. As all your problems are pretty new. Sometimes you might run into performance problem. Sometimes you might run into fault tolerant problems. Sometimes you might run into, let's assume that my software defined load balancer is down. I have a service, I scaled out 3 times, but my software defined load balancer is down. What would happen? If I have 3 instances of a service 2, so 2 is running 3 instances. So I have a service discovery which will perform a load balancing, which is software defined load balancing. and it will go and pick, okay, 2, 1, 2, 2, 2, 3. The request is round robin, right? Assume that my SDL, software defined load balancer, is down. It's not working. What would happen? Mm-hmm. It will always ping only one endpoint. So it will not, the system will not go down. When a software SDL goes down, it will always go to the latest endpoint which the proxy captured till now. So proxy has its own, what we call, the hash table. So proxies typically have its own hash table. It will get the dictionary of all the API endpoints, and whenever proxy call the service discovery tools, it will just go and check the healthy endpoints, and it will keep refreshing the cache. So if my software-defined load balancer goes down, my scalability goes down. Rather, my whole traffic goes to one endpoint, which is the last endpoint it recently sent. So imagine that situation comes in. So those are the problems you typically run into. Now, in that case, your business cannot go down. You have to scale out, but you cannot scale out. The best option typically we do is scale up. So we'll see which machine the endpoint is hosted and how much traffic it is going, and then we'll immediately increase the RAM, the processors, and everything, so that my current business will keep going while I'm working on my defined load balancer. That's what we do. So the more you're trying to solve the problems, you will try to understand, okay, how to solve it and what type of design I need to bring in, right? The next thing is DevOps CI/CD. That's a pretty common term nowadays, but the intention over there is fully automated, right? Let's assume that we used to have a configuration management team and all in the middle. Okay, they used to maintain our configuration, they used to maintain our properties, they used to maintain our code versions, etc. Now you don't need that. The minute you adopted some GitLab, Sonar, blah, 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 and all these tools, you can automate everything, and the developer can push the code all the way to, and the testing frameworks also need to. That's where the discipline fails. Typically, we always say that fine, and developers don't go for scenario tests, unit tests, etc. That's where the quality fails. And anyways, people process technology changes, maintenance and feedback it is always required that whenever a service is gone to the live, we should get a feedback. And the feedback is provided by multiple systems. One is the QA systems. The second one is the telemetry systems. The third is the business itself will monitor the services and they'll give the feedback. So all these things have to be taken care of. And you need to adopt a platform for these architectures. If you go with VMs, I'll show that one too. If you go with the VMs, the problem is the dynamic scalability, whether it is scale up or scale down or scale out, all these things is really tough to maintain. So we went through that challenges. It is better to have a platform so that you have better visibility and better dashboarding. If you don't have that in place, then end of the day you are using you're going with blindsided by having a VM. And VM, how many containers you can host, you don't know. How much RAM it is being used, you don't know. But there are some tools, I'll show you those too, which we can utilize. And deployment strategies, there are 5 or 6 deployment strategies, blue, green, and then override, create, all these things. So there are various deployment strategies, right? For example, if I want to host if I already hosted one service and I want to go with a new version of the same service, then you need to think about blue and green. So you want to keep the blue active and you want to move towards green and see how I can switch the blue and green. And then sometimes you want to kill the blue and you want to move towards green. So how to do that, all these things. It's all there in my blog. By the way, I have a blog which it's there in my introduction. So I put forward all these things, like what type of strategies are there, what type of platforms are there, and how the people process technology will back, etc., etc.
These slides there.
These slides are not there. I'll upload these slides. So, okay. So I know we speak about technology. I know this group is on technologists. No offense over there, but I want to make sure that when you're thinking about technology, those days are gone that you should think only from a technology perspective, because it is evident that you're looking from a business perspective also. So in these architectures, what happens is you're building your services from a business perspective, not from a technology perspective. So service can be a customer, and a customer can have many services, web services. Let me change my language. From a business, it's called a service. Customer onboarding is a service. From a technology perspective, there are various technology endpoints you'll end up doing. What does customer onboarding do? We'll take the customer information, we'll create a prospect account for him, and then we'll associate an ID, and then we'll send out an email saying that, dude, you are on my in my list right now. So these are the 4 or 5 actions we are doing, right? So those 4 or 5 actions combine together into a package and ensure that that package is being shared across your organization, and the same package is being distributed and shared across wider LOBs also. So that's called a microservice. A microservice is a group of functions which is trying to solve a business problem, and that microservice is being shared across the LOBs in an organization or an enterprise, and making sure that that microservice is a standardized API so that the term of the customer inside an organization can be shared across. It's a unique language. So the language between business and IT also will be streamlined with this approach. So this is one sample where we are saying that, I have a market and I have a bundles or packages. So in that case, I have markets. So let's take this one. I have bundles. I think there's some more. Yeah. So I have all these business contexts, which is market, auth codes, bundles, package groups, etc. This is not the right way, actually. I think I wrongly did this. But let's assume that you healthcare, right? Your members, your what you call this? Your members, and you have claims. You have providers. So member contexts typically take all the members' information. Sorry. Members context will take all the member onboarding, member details, member family details, etc. But when I go my claims, members need to ensure that the claims are associated to the members, right? A claims cannot be by itself. Claims you can only retrieve by members. So the context is mingling over there. So that means your members context is there in the claims context. So you should ensure that your service is being, or your API is cross-domain, and it is being shared. So any change on this version of the API will impact here. So all these things have to be taken care of. Let's go into this is how the greenfield or brownfield implementations go. So let's spend some time on the code as well. So this is the typical reference architecture, logical architecture, right? So in the proxy zone, you always have a logging service, a software-defined load balancer. You can have a routing. You'll have a circuit breaker, service discovery, authentication, authorization, or RD. So these are the typical things we have. And apart from this, you can always have a response cache, etc., etc. Okay. And ideally, beneath that, you always have your services. We recommend don't go with packaging of one structure. Have your services in such a way that your business is isolated to that of your CRUD operations. So keep your data services isolated to that of your business services. Generally, what happens is we club. So let's take a simple application, right? I have a members or customer application. I can have a customer application which is get, put, post, and delete. But behind the scenes, I should ideally have a data service for the same customer to perform this database operations. That's how we recommend from these things. And sometimes if you want the context to be shared, we go with event management, saying that, okay, I publish my events to here, you can subscribe to whatever you want. So that's how we go with inter-service communication or inter-process communications. And we divide the services based on different types. So let's take in a simple application, what all we have. We'll have a web application, we have a gateway, we have a message broker where we can publish the messages, and I applied some technologies over here. So all these are open source, by the way, just in case if you want to try it home. So we use Elasticsearch for monitoring, and we have Console for service discovery. We have config server for externalization of configurations. We have Zipkin for monitoring, tracing, and Spring Boot admin for monitoring. So we'll see all these things right now except this part. I'm pretty poor over here on web, but we'll see all these things right now. Okay. Any questions before I go into the code? What is it? Yeah. Okay. Okay. So let's start with something. Okay, let me show all the tools which we are going to use today. Oh, my Docker is up and running. So I have a Docker of console which is running. So if I open my console, so you see a console running, right? So what does console do? As I mentioned, it will register all my services. The minute I start a service, it has to display over here. And all these greens, yellows, reds, typically it shows if a service is up and running or not. Okay. So this is a service discovery tool. Then we have a Spring Boot admin, which will give me the health of my services and the memory management and everything. Service discovery. This is 8500, local host 8500. I mean, so I'm hosting all these things in my laptop. So that's why you're seeing as local host. And typically their port is 8500. So let's see. So this is where we monitor our services. Okay, there are various tools, by the way. Okay, we have Elasticsearch, we have Splunk, we have Spring Boot admin, but the tools like Splunk and Elasticsearch are mostly for log aggregation, visualizations, machine learning based on the visualizations, all these things. So let's assume that if you are using for business and you are looking at how many claims I'm searching or how many users are searching for the claims every day. If I use tools like Splunk and Elasticsearch, I can generate a report saying that, okay, East Coast, there are so many members who are searching for my patient search or are searching for my claims. So I can get some machine learning algorithms, which is built into those products. I can use them and get more details around my data. These are pretty straightforward. These tools like Spring Boot admin, Zipkin, and all these things, open source products again, these help you in identifying, okay, how much of my service, how many instances are running, how much of it is transactions I'm getting, how much of RAM I'm utilizing, etc. Okay, that's what we're using there. So I have a proxy. So I'll run this proxy. So the minute I run this proxy, you can see here that it gets registered both here as well as here. That means it is just started registering. It is trying to figure out it is still not healthy. So when I check the health, I'm getting that it is failed. Now it is passing. So the advantage of this one is, let's assume that I'm scaling out my proxy by 2 times. Okay, my only goal is scale out the proxy, just deploy another jar or another application or another Docker. My tools like console will take care of, okay, guys, I have 2 versions or two instances of proxy. So I have to do a round robin between those 2 and check the health of the service. So if one of the proxies goes down, it will show me orange in color, which means it will decide that, okay, one is healthy, so I have to send all my traffic only to one. So we'll check that one too right now. So this is a proxy. So what does the proxy does is it will take all the information when I click on the proxy and slash the context path of my service and slash the endpoint. What it does is it will go search for the endpoint from the console, get the endpoint, and route the traffic to that specific endpoint. Is it clear? Okay. So now I'm starting one of the sample application. Okay, I was trying to do a config server to fetch the configuration directly. Somehow my GitHub seems like not responding. So I have to remove the config server for this test. Hope it works. Sure, it's working. Right, so let's see here. Still not up. Okay, now it's up. Okay. Now let's look at the Spring Boot admin. So it shows that I have two services running. Look at this. So now I can see how much heap size it is using, how much non-heap size it is using, etc. Now if I want to test this, so let's work on scalability now. So you understood the service discovery, right? Service discovery is the only thing we do is if I have, so right now I see that there is only one instance running. So I'll deploy one more instance and see that how the scalability will work out as well. So let's go with the proxy now. I have my proxy running on 8443 and I have my test application running on, let's see, running on 8081. Okay, so the best way to reach that application is context path So I did not hit this URL directly with 8081. I'm going through the proxy over here. So what does proxy does is it will search for this test CDS from my console, from this endpoint, and say that, okay, I have one running, so I have to redirect that URL to actual test CDS and the Swagger definition, right? Now let's go with the scaling out. So I'm building the same application, that is my test CDS, and now what I'm doing is I'm going to run this on a different port. Okay. I have one more port which I'm opening, the same application, that is 8081. And now we'll be running it on instead of 8081, we are running that on 9000. Application failed. Wait, yeah, you're right. It is still taking the old port, you're right. Should be up and running now. Oh, connection refused. Two instances, okay. Now you can see two instances running. One is on 8081, one is on 9000. Now if you should see 4 over here. Get this. Going through 4. And if I run my Swagger, it's going one on 8081 and one on 9000. I wish if the config server works, then I could have displayed that error by applying something, some dynamic this thing. But I hope you understood the service discovery, the monitoring, and how we are going to do this proxy. Are we clear till now? So we just check the service discovery, scale out, and we also check the Spring Boot admin. Now let's also do the event driven. So I'll kill this one instance for now. Can you please repeat? For the whole thing? Yeah, everything is working. So I have Minikube running over here. So let me check the Minikube. Okay. So I have the container of the RabbitMQ running over here. So if I try the RabbitMQ URL, so I have RabbitMQ Docker running over here. Okay. So this is what we're going to publish the events now. All this code also will be available on my Git repository. I'll share all these samples as well. Run my business. Let's see. Connection. So there is one connection which is connected with guest. So we have it. So this application is running on 8085. So let me publish an event over here. By the way, this is also registered again in console. So there is an event listener. So the minute you run the application, it will get registered. That's why we typically go with server-side service discovery product as compared to API gateways in this kind of microservice architecture or cloud-native architectures. And if a service goes down, look at this, it starts showing error. They're saying that one of your services is down, so I cannot do anything. So now let's go fetch that URL. This is another example where I publish my events to queue, and I can get that events back. Mhm. Can you please repeat?
In one package,
Mm-hmm.
can have service deployed.
Oh yeah. So what you're saying is I want to have an API with two endpoints. One is, or I want to have an API with which performs the typical CRUD operations. Along with that, I want to publish a message to the event, right? So that's what we're doing right now. So I'll walk through my code. So if I look at my code, if you look at my code, you'll see that I'm publishing an event. At the same time, adding that user to one of my collections. So that way I have two channels exposed. One channel is publishing, the other channel is just performing the CRUD operation. So that way what happens is, in these patterns, again, that's a good one. So in some of these cloud native patterns, assume that I have a request coming in, and though I need to publish to my queue, along with that I need to add to my system. My adding to my database fails because database connection failed. So in that case, I have my message published always in the queue, right? So if I have, but that is only for the consumers. I'm not going with patterns like circuit breaker where just in case of failure only I want to write it to an event, or else I do not want. So if you look at Amazon, so Amazon's order service works like this. you can push your order. Then behind the scenes, what is happening is it is publishing everything into the events. And the minute the event is published, there will be a listener which will listen to that event and process it. Imagine a situation that my order of my payment service failed. In that case, all my events, so there is no way that Amazon is directly going to the database. So most of the Amazon services are written like this. Amazon services are always written in such a way that it will call from A to B, B to C. And typically we have these event events. We have the events always between here. There is no direct call. It will publish here. And there is this service C has two endpoints. One is a HTTP endpoint. The other one is a TCP endpoint, which will keep listening to this. And along with that, there is another. So there are two types of TCP. One is TCP listener. The other one is RPC. So most of the if you look at either Google, Facebook, or any of those guys, most of their channels have HTTP, RPC, and TCPs. All the three will be there. The reason being, HTTP sometimes it acts slow. So some customers go RPC with them. On TCP, they'll always have a listener listening to the queue. So every service, inter-service, every communication from UI to the service to other service to database, it's always events. In any situation, even if the system goes down from all the way from here or from here, including this one too, by the way. This is my session that I have UI here. Okay, event UI goes to the event, by the way. Then service, then this one. So anytime, even this whole thing goes down in Amazon, this business still continues because your UI is up and running. They're publishing all their messages to the events. So that way, your order is just getting delayed, but they're not losing their business. They're making sure that they get the orders first. That's their motto. And then they move on to the next level. So that's from most of the event-driven patterns typically drive from them because they ensure that the business, I still remember in 2011 or 2012, their payment service was down. Within a day, within a few minutes or few hours, they came back and said, guys, don't worry, you place your orders, we'll take care of it. It took some time for them to mature, but one of my friends works there, so he was mentioning that, including the UI, every request goes first to the queuing server, SQS. From SQS only, they process the next steps. But why I'm showing this event-driven services also is, you are not writing a complex event listeners or anything. Your frameworks or chassis frameworks are so matured enough, the minute you publish the event, you have a listener listening to that. You're not writing any schedulers or anything. So it has the built-in schedulers built into the chassis frameworks where the minute you publish it, there are listeners which will take it. So I'll show you the code also. The number of lines of code you're dealing with the minute you adopt the chassis framework is hardly 2 lines. So we'll walk through that right now. Okay, the combination of my chassis? Okay, so we'll go there. I'll do a whiteboard again. Okay. So a chassis is a combination of various tools and frameworks, right? So what all we require in chassis is service discovery, we see discovery, configuration should be dynamic, monitoring, metrics, edge gateway, tracing, event management, These are the fundamental things we typically need. Just thinking anything else. This, actuators, proxies. Yeah. Chassis, typically we call it as frameworks. So chassis, you can build your own, or you can use something. The market currently, we have 3 or 4 leading frameworks. One is Spring Boot. The other one is Wildfly. The third one is WSO2 MSA. These are the 3 currently leading in the market. Wildfly is a combination of JBoss and Apache. JBoss and Apache. This is Spring family, and this is WSO2 family. So these are things. So now Edge Gateway, if I go with a Spring, I have something called Zool, right? If I go with the Wildfly, they are using Envoy. Service discovery. If I go with Spring, they have something called Eureka. If I go with again Wildfire, you have something called Envoy. And the open source, you have EdgeSet, Console, etc. Config server, we have Spring Boot config. Typically, this is very small in change, so it's the framework. What is the code inside this is nothing but it's if you understand sidecar pattern, right? The sidecar pattern is basically you have an application running, that is one container running, and there is another container which is keep on listening. Okay, this container keeps listening to the other container. This is called sidecar pattern. So what Spring Boot does is Spring Boot has something called Spring Cloud Config dependency. The Spring Cloud Config will keep listening to the Spring Cloud Config endpoint always every 20 seconds or so. So this Spring Cloud Config will go get the all properties from Git or Vault or anything like that, and then it will fetch all the values and import over here. So just in case, let's assume that I have value which says 1, 2, 3, and here also it is 1, 2, 3. Now I changed it to 4, 5, 6. This keep listening. We have an annotation called refresh scope. If you add that annotation, what it does is, whenever there is a change, it will done, even though it is running in the JVM, it will go and change the value from 1, 2, 3 to 4, 5, 6. So that's how we typically get this dynamic configurations.
So the changes atomic because the dependencies.
Does
it change it as an atomic entity?
Yeah.
That's when you have.
Yeah. So let's assume that, so when you said atomic entity, you mean say that specific entity?
Well, if I have multiple values of configuration, so it's that update atomic because it's updating one, updating in the process of.
Not just one, it will update all. So let's, to your point, let me understand your question again. So I have value 1, value 2, value 3, right? And in my class, I have @value of 1, @value of 2, @value of 3, right? So this is my project, this is my class, okay? Now let's assume that here I added @refresh scope. And this is calling config server, and this is there inside my GitHub or somewhere. So now if I change this V1 from 1 to 3, A, B, C, X, Y, Z, let's assume that these are my default properties, right? Now if I change 1, 2, 3 to 4, 5, 6, A, B, C to D, E, F, X, Y, Z to, again, might be alpha, beta, gamma. So in that case, all the 3 values will get changed.
Right. The question is, me as a consumer, I'm using those properties. We have a condition where it's atomic, so will the seed clean state, or could it be a flux where it's being updated as I'm reading the property?
No, it updates all in clean state. Yeah. Why do you require, especially these values, why you require conditional values?
question is, like, a new instance that's created, so I've always got a fresh copy with valid values, and those values be lots of updating. V1, V2, my request comes in, all V3s being updated to get the config, so I get the new V1, V2, and the old V3.
Oh, okay. So you're referring to will all these values at a time, or it's like sequential way, so that if my transaction is going, no, it's all once. Yeah, you're right. Yeah. So what it does is it takes in the refresh scope. If you look at the refresh, the way the logic inside the refresh scope is written, it will fetch all the iterate values. It will put inside a hash table. So all at once, the hash table, the hash tree node, what it does is once the values are changed, all these fresh values will be updated one shot inside the refresh scope, and then that changes that reflects on my property as well. So it's all one time. So that's your external configurations. And for monitoring, you have multiple, but typically you have Spring Boot admins, or you can go with Prometheus, or again Elasticsearch or something like that. So for this Prometheus, again you have dependencies where you can add, which it will give. So the way our Spring Boot admin is giving about how much is the heap size it is using, how much RAM it is using, it will give the same way. Prometheus is the open source tool which will give the same way. You have Prometheus, you have Elastic, etc. And for metrics, again, Elastic, Splunk, etc. For tracing, Zipkin, and you also have something in, I think the Istio users are Envoy users Zipkin only. Event management, again, you have a couple of frameworks, actually a few frameworks for that. So if you look at some of the applications require CQRS pattern, which is command query read write applications. So let's assume again the Amazon system, right? If I keep writing to the database, there is a property that I might run into deadlocks, or I might run into some overloads, everything with the database. What they do is they separate the reads and writes. So that pattern is called command query read write segregation. In command query read write segregation, what happens is transactions which is trying to write, it will go to the queue, and I have a write service separately which will take these transactions and write behind the scenes. Okay, and I have a read. If I'm doing a read, it will go directly and fetch from the actual source of the data, source of the tool, and read it. So typically we keep that. If I have too much of database transactions, especially in the retail, we typically adopt this read write segregations. So those patterns, again, Spring Boot, and there are a couple other which I don't have on top of my head. And again, they follow the same event management.
Where would you use the separation of read write versus scaling up your data?
Okay. So if you would have seen my architectures earlier, there is one architecture in starting which is called service-based, right? So in the service-based, what happens is all the services are writing to only one database, right? In this case, what happens is if there are services which are reading, there are transactions which are being written, typically we are burdening this database. Even though you scale up, okay, it is difficult to scale out very easily with databases like Oracle, unless it's a NoSQL. If it is Oracle, if you are trying to scale out, you're bringing partitions over there, which is really challenging. So what they do is they go with read-write segregations. So all the reads will happen directly from here, and the writes go over here, and from here it will come to the database again in a sequential manner. So these are especially when we are doing mostly non-transactional immediate, so claims, right? I don't want my claims to see immediately. I want my claims to see after later on once the claim is submitted or the claim is in the process or anything. But for doctors, for providers, the claims keep on coming over here. Right? I don't want to burden my database with all the claims coming from various providers. I would rather keep everything in the file and then I'll do it over here. And for reading, so this again Captiva. Consistency, availability versus consistency, and partition tolerance versus consistent availability and partition tolerance rather than consistency. So based on which parameter is important for you, you'll adopt that. What is it?
The write is another service.
Exactly. writes it all again in the services. That is nothing but your event business.
You mentioned that the services company was Eureka.
Eureka is from Spring Boot family. Yeah. This one is Console. Yeah. Exactly. The reason being, Eureka was when it started, it's a client-side service registrar. That means client has to himself go and say that, dude, I'm joining in, I'm coming in, so I want to register it myself. This is an agent-driven. So there is a protocol called Gossip Protocol. So if I have an agent running, then what my agent does is it will go search all the APIs which are running on that hardware. It will register over here. So instead of client going and saying, Eureka, please welcome me, I have an agent which will take all my information and put it inside my Eureka or Console, something like that. So the beauty of these agent-driven architectures is the agents will help us in getting all the information of the health in a real-time basis, rather to me and going every time and register. So I don't need to worry about, okay, how should I register? What protocol I should use? What type of IP and port number I have registered? All these things I don't need to worry about it. Let my agent take care, choose about the right port, and then register myself over there. So that's why we use this agent-driven architectures. Okay, so I have a service which will publish a message. Hope it works. Okay. So I have a message published over here. Let me run my listener too, so that way I can see all my messages. Yeah. Hmm? Can you please repeat? Can we have n database transactions, sir? Non-database transaction in Spring Boot? Yeah. So right now, so if you look at all my web service content, it is nothing but adding to a collection. There is no database involved over here. So everything I'm writing to a collection. That's it. So you can always have a simple business logic-based services also along with the database-driven services. So look at any rules. Oh, okay. So you are now saying orchestration, where if I have an orchestration of services, and if one transaction failed, can I roll back those transactions? Yeah, we are now using the JPA's transaction statements over here, but typically, if you are trying to achieve an orchestration between service A, service B, service C, between 3 different containers, no, you don't have that privilege, because it's all running in the separate JVMs, right? So you cannot control a transaction between the JVM. Within the JVM, if you are trying to control a transactions, and that too, with database transactions, you can hold it, but not outside. That you cannot do it. So let me quickly check what is going on in 88. How is it running in 88? So everything in this one. This. I am getting connection refused. Okay. Sorry guys, somehow my listeners is not behaving well. It is trying to ping 80, 88, 88. Not sure what is running in 88, 88. See what is dependency I'm running. Stream, Rabbit, Discovery, Actuator, this Actuator. Okay. Continuously pinging. Okay, let me remove the Spring Boot admin part of it. You see that? I don't want to register in Spring Boot admin. Guess it's working. Okay. Now, yes. Okay, let me see if this still, it's just a warning. So, have 3 socket connections. Let me post a message again. It has posted successfully. Have messages here. Some queues. Customer queue. Message. Queue is empty. Here. Queue is empty. Sorry guys, something is going wrong with my publisher and subscriber. It is creating the topics, exchanges, and queues, but somehow it is not reading from the queue. The message is being dead immediately. So uh, there are 2 different use cases, right? This is an error, so unable to create. There are 2 different use cases, right? RabbitMQ is for event-driven systems. Kafka is message streaming systems. So, sorry guys, what I'll do is I'll upload this working code again into the Git and send across, update that in the event. So I'll do that one. I'll provide this code again, working code. But if you look at the code, I'll come back to your question very, very soon. I just want to walk through the code. It's pretty straightforward. So what happens is in the consumer controller, I just want to give what type of queue I'm dealing with and what type of channel I'm associating my queue with, and just the queue, and that's it. I read my message. Is it better? Okay. So we just need to create a channel, and so there are 2 types, right? If you don't go with chassis frameworks, you'll. Bear with me, man. It's acting weird. Let me see how much RAM I'm using. Wow. Okay. I have too many things running. I have a OpenShift platform running. I have a Kubernetes running. So, okay, it freed up 5 GB, so which is good. Okay. So, typically, if you don't go with any chassis framework, what happens is you'll end up using AMQP templates. AMQP is again, see, JMS was the previous specification. AMQP is the latest specification, right? So, if you go with AMQP specifications and AMQP templates, the amount of time you would require to to write, the amount of lines of code you will end up writing the code for this one is at least 20 lines. So for the same thing now, if you look at adopting a chassis framework, it will end up having one annotation and one this. So first thing, I would strongly recommend that even if you are starting your new projects, I strongly recommend annotation-driven development because that will provide better code quality and less number of lines of code. So annotation-driven development is what we typically follow in Java and even .NET if someone is from Microsoft. Attribute-driven programming. So adopting a chassis framework really leads to like 2 or 3 lines of code for event-driven programming also. Okay, so I'll make this work and I'll upload into Git and I'll inform this event manager. So coming back to your question, yes, look at Kafka and RabbitMQ 2 different ways. Kafka is a data streaming system. So what that means is, there are no publishers and subscribers over there. It's purely producers and consumers, which means I can produce the data and the data will still live over there. There is no end time for that one. Until you have a consumer over there, the data will sit there. And the data is partitioned across multiple clusters with various footprints. If you look at AMQP, it's purely like publish and subscribe, where I always require a subscriber. If I don't have a subscriber, I'll remove the data because I don't need the data. And every time, if you look at the performance also, right? First, TPS, if you look at 60, 100, that's what you're looking at RabbitMQ. If you're looking at Kafka, you're looking at millions of messages. So per second, you're looking at thousands, at least 100,000 or so is what you're dealing over there. Here, it's like hundreds, close to 1,000 messages, not beyond that. So the use cases are completely separate. And where we use streaming systems like Kafka is when I have significant number of transactions, log aggregators, or I'm getting too much of data where I need to perform some kind of data analysis on it. There I get all the data, and behind the scenes I have some tools, some systems like Hadoop or something, where I'll fetch the data, push it to Hadoop, and slowly on top of it, I'll apply some machine learning or some kind of AI tools to either use for some data analysis or data analytics or something. But it is not a transactional data. It's purely the analytical data. That's when I go with Kafka. But if I'm going with transactional data and I want the publish and subscriber where I publish the data and I need the subscriber and I want the transaction to be thoroughly monitored end to end and the transaction I have to make sure that it is reaching the destination, that's when I go with JMS or MQBase. That's how it is. But yeah, it's 2 products and the framework is the same. It's just that instead of RabbitMQ channels, you call it as Kafka channels. But there, the number of transactions is 10 as well. So that's pretty much I have from this one. And a quick overview, if you're interested in Kubernetes and these things, is I put together some drawings over here where how the Kubernetes would look like. First thing, let's see if my Kubernetes is open and up and running. But Kubernetes is fairly straightforward, guys. I don't think so. It's not that complicated. Come on, open up. Okay. So we always have something called pods, and pods are associated with services, and services are associated with node ports, and finally node ports are associated with ingress. So pods are nothing but your lowest level of container, but pod can have many Dockers, by the way. Okay, a pod can have one or many Dockers inside that, and each Docker communicate with the ports inside a pod, and between the pods you communicate with using IP address and the port. So a pod can have multiple. The problem right now in the current architectures, most of the developers or architects I'm looking at is they take this pod as the lowest level and they push the whole package of the whole project. The way you push into a JBoss or Tomcat or WebSphere earlier, you're still building the same way of the huge package and pushing into a pod. So they're using pod as their virtual machines. I strongly recommend don't do that. You should use your pod for something like this, where I have my customer service. So I have my Spring Proxy for proxy, I'll use a pod. Or I'll use pod for proxy and config server, bless you. I'll use pod for proxy and config server. And I'll scale my pods. But I cannot put this whole project. That means this whole package, all the packages like this customer service, the listeners, the proxy, the config server into one pod. That is not a good practice. Pod can be isolated with a business function or by a technical function. So I can have a pod. A pod can have containers, that is Docker containers, and pods are associated with service, and the service is associated with the proxy. So whenever I generate a pod with one Docker, it will be settled over here, and I can see the health just like here. I can see what is the health of my pod, and every pod is associated with a namespace. And inside the namespace, you can give your ports and everything. Okay. The next thing is how to access my service is by node ports. These are your node ports. So you give your public IP address, and then you can route your traffic to the public IP address of the node ports. Okay. The next one you have is load balancers. So on top of the services, you typically have load balancers. So you can scale out, you can replicate your pods by 3 times, 4 times, it's up to you. And pods run on simple YAML files. So these are your, this is how a simple pod file would look like. So first thing, I have an API. What is, oh, yeah. Okay. Okay. So most of the pods are Docker file, by the way. Yeah. First step before the pod you need to do is Docker. So let me open one Docker file also. So first thing you need to do is generate, package your application, and then send it to the Docker. Okay. So from a Docker perspective, you're just trying to pull the image first. Then you're trying to create a directory. It's just like your any Unix server maintenance only, right? Then you push your jar file and you're exposing a port out of it. That's it. And once you generate this Docker, you can just say that Docker push and you push it to your repository. Once you push it to your repository, the next thing is you want to pull that Docker from the repository and push it to the Kubernetes. So that's what I'm saying. This is my Docker Hub account, and this is my Docker, sample Docker. So I'm just giving a pod with a namespace and a label associated to it. And I'm just giving a container name for each of my Docker and the image what I have to pull. By default, it will go and fetch from Docker Hub with the port name. And what is the port I want to open with. Then on top of this, I need to open a node port. This is the port which I'll be used for publicly accessing that Docker or the application hosted inside the Docker. And then I'm associating a service to that Docker, to that node port, so that if load balancer is applied in front of it, the service will take care of routing my traffic to 1, 2, 3 node ports. Yeah. Cops. Yep. Exactly. Yeah. So Kubernetes, you want to use Kubernetes as your service discovery, you can use it. Why I separated these two is Kubernetes, I personally treat that as mostly the hardware maintenance, like pods, Dockers, and everything. If I start clubbing that with my actual endpoints, it is a little cumbersome to maintain. So if let's assume that I'm running an organization, right? And for me, all these are multiple projects. I deployed one big Kubernetes cluster, and I gave one cluster to you, or I gave one endpoint to you. And I said that, okay, you can upload your parts over there with your own namespace. Then I asked other gentlemen to again use the same Kubernetes, apply his projects also over there. Now, you can see your services, he can see his parts and everything, but that gives me only the parts. And for me to maintain all those parts, I have to look at it from a bigger dashboard perspective. Rather, if you use a tool like Console, it will isolate the hardware to your web services. You're saying that I only care about my web services. You take care of scaling out my parts. You take care of scaling out my Dockers. My view is I don't want to see the parts and everything. I want to see how many instances of my web APIs are running. The language changes between an infrastructure management versus application developers or application architects, right? Infrastructures typically look at parts. Applications look at how many services I'm running. So that's where it's more like your comfortness. That's what we deal with. Yeah. So as the next step, what I'll do is I'll upload these slides into. I don't know whether there is any platform for DCJack, but I'll upload into my blog, and my blog URL is there in the event. You can download it hopefully next Monday, and you can download the samples also from my Git repository. I'll put a cloud native group over there, and I'll put in the deck itself. I'll add the GitHub link where you can get it. I also have my own personal chassis framework. You can play around if you want to download from the GitLab, but that is again my own chassis. So I don't maintain that. I don't update it. So it's up to you. Any other questions, guys? Okay. Thank you all for your time. Thanks for coming. Thank you. Thank you, man.
Thanks a lot.
Oh yeah.